Hello, my name is Rez, and I am a professional game programmer, and I do electrical engineering as a hobby. This is the Robot Advent Calendar, and this is a technical video. So I just want to talk a little bit about these guys. These are really cool, these opto transistors. I'm not going to go through a lot of the details just because they work very, very similarly to the the basic transistor. You can just think of them as light provides, like it's the amount of light. So that same thing of transistor man, right? Transistor man is looking at the current between the emitter and the base. Well, in this case, transistor man is looking at the amount of light that this sensor is seeing. And as I put my hand over it, the light, of course, goes out and it comes back in. And we can see it here on the meter. This is measuring the voltage across both the LED and the resistor. And what this is doing is we have 4.3 volts across this. The other 0.2 is going to be dropped across the sensor. So as I cover this, that voltage plummets, right? I completely cover this as much as I can. Now only 2.3 volts, 3.4-ish volts is being dropped. And that's not enough to bias the LED. Remember, with diodes, with any kind of PN junction, you have to have enough pressure. You have to have enough of that pull to rip those electrons through that PN junction. For LEDs, that value is quite high. You know, it's a couple volts or something, 2.4 volts-ish. And so if I do this, I don't know if it's just like, yeah, I can see just a tiny, tiny bit of glow. It's very, very, very faint. So it is biasing it just slightly, but I mean, obviously not enough, as you can see. So they're really, really cool devices. The last thing that I want to show comes once again from open circuits. Now I don't have an opto transistor thing. I don't have a phototransistor, but I have what's called an optocoupler. Half of an optocoupler is a phototransistor. It has two components. An optocoupler has a light on one side and a phototransistor on the other. And so what you're basically doing is on one side, as you pull current to light up that light, it's acting as that base. Here's what it looks like on the inside. It's all discolored, which is interesting. I didn't know this, but it's discolored just because the LED has been on for so much. There's a little silicon chip in here. And so it works that same way. I don't happen to have one here. They're really cool. They're really good for decoupling entirely, right? So you can have a current on one side affecting stuff happening on the other side, allowing another current to flow on the other side, but they are physically disconnected. They're physically isolated, which is a really nice thing. It's just light. It's just responding to the light. So they're often used for like this looks like a power supply here. So that's an optocoupler, and I kind of love them. I should just get some. I don't know. I don't have a real direct use for them, but I just think they're neat. But yeah, it's, you know, half of an optocoupler is just our little phototransistor. Okay, that's it. A short one today because there's not a lot going on. I'm curious what they're going to do next. We've got some sensors, we've got some things. A microprocessor is going to have to come up at some point. We're going to have the other transistor to build an H bridge. As I said before, I think we're going to have a total of 4 transistors. It takes 2 to build one side of an H bridge. So I think that's where we're going, but I mean, I was super wrong about some other stuff, so we'll see what they have in store for us tomorrow.